So guys, the next question is reverse a singly linked list. Obviously, this is a pretty standard question of linked list and it is one of the most asked question in the interview. A lot of time this question is asked in the interviews. This is one of the interviewer's favorite question. So what a linked list looks like is, guys, we have a head pointer that is given to us in the question. So basically, if this head is given to us, we can identify the whole linked list because they are linked one with each other. Okay, and we need to reverse the linked list. For example, now 1 is pointing to 2, 2 is pointing to 3, and in this fashion. But at the end of the iteration, we need to return the address of the first node of the linked list, which will be the last node. I have to return the address of this particular node over here. Why? Because this will become my first node, because the entire list will be reversed, and so head will be pointing over here. So I need to return the address of this node. Now I would like to start with a little bit of basics of linked list, and that is what is this pointing? What do I mean by this pointing thing over here? Suppose in binary search also, what I did was, suppose there was a array of this size 5. So I was saying that the start is pointing over here and the end is pointing over here. What does that mean? That means nothing but this start has a value of 0, so it is pointing to the 0th index, and end has a value of 4, so it is pointing to the last index 4 over here. So that was the meaning of this particular thing. Over here also the concept is same. Every particular node is divided into two parts. The first part is the value part. Over here in this question, we are given with integer values, but the values can be anything from double, string, character, it can be anything. And the next part is over here. What is this next part? This stores the address of the next node. This is linked list basics, right? So as this node over here, then in this white, what I have done is I have tried to write the address in which a particular node is created in the computer's memory. Like for example, I have taken simple examples, right? Suppose this particular node is created at memory location 100 and this node is at memory location 200. So this head over here, what it does, it stores the address of the first node. So the address of the first node is stored over here. After that, then in the next part of the first node, we store the address of the second node. And similarly, we keep storing the next node's address in our next portion, and this is how we keep chaining things. And obviously the end of the linked list is marked by a node which will have null in its next portion. Basically it refers to no other address. So basically this is the end of the linked list. Now another basic that I want you to visualize before moving ahead is that in a linked list, what we do is, this linked list has one next part. It has one next part over here, right? So every linked list can point to only one node only. There might be a possibility that there are multiple nodes that are pointing to the same node. There might be a possibility. In all the next part of these nodes, the address of this particular element is there. That is possible. Many nodes can point to one node, but one node can point to only another node only. It cannot point to multiple nodes. This is not allowed, because it has only one next part. It can store the address of only one node. Well, there are certain techniques where we can accommodate more, but simple techniques, what we are assuming is that it can hold only one address, right? So as soon as we create a new connection, for example, this is a node, I want to create a connection, I want to reverse the connection. So basically this node can point to this node over here. So as soon as this points over here, that means that in the address part of this node, we store the address of the previous node. That's why it will point to this node, and immediately this connection will be broken, right? So first let me start with, if you come across this question for the first time, maybe you will think of taking two pointers, suppose before and after, or for example first and second, for example. These are the name of your pointers, and what you will try to do is you reverse this and then again move your first and second pointer and then try to reverse it, right? This would be a first thought process, right? But let me just make it very clear to you that you cannot do this using two pointers, because let me give you an example why. Because for example, first what we want is, we want to make this connection. So in order to make this connection, if you want to make this connection, what you have to do, you have to write, this was, suppose this was first and this was second, right? So you would do second dot next equals to first dot next. This is what you need to do, because this second dot next, the value of this second is 200. So second dot next is nothing but 200 dot next. So in the 200 dot next, this is referring to this address over here. So in this address, you will replace it with first dot next. So basically 200 would come over here. So it should point over here, and this link would have been broken. Now after the link has broken and this link has been established, this is your first and this is your second. You don't have any connection left with the latter part of the linked list. This part you don't have any connection to. You have lost that part because there are no existing connection and there are no pointers that is holding the address of the next node. So once you reverse the connection, you lose the latter part of the linked list, and that is why this is the problem, which is why you need to keep a track of the next part as well. So we need 3 pointers at a time in order to solve this question. Now another important thing is this 3 pointers, they will not be starting from the first node over here. They will be starting from one place ahead. This will be your position of your previous, this will be your current, and this will be your next. This is the starting position, right? Because we have to reverse this connection as well, because once we have reversed, I showed you how once we reverse this connection will be built, this connection will be removed, but this connection still stays. I should put null over here as well, right? So this is another thing, that my previous should start from here, so that I can, in my current dot next, I can put the null thing. So that is why my previous should initially be null, which is basically, it is referring to a place before current. Current will be initialized with the first element, so previous has to run before it, so we take a null as previous. This is the simple thing. Okay, so we would need 3 pointers now, you know, and I think you will be remembering this for your entire life, that you would need 3 pointers to solve this question, reversal singly linked list, right? So let us now see how the things will work out. So basically what we will do is, I have a previous which is basically initialized with null, and then I have a current that is initialized first address of the first node. The address of the first node is nothing but head only. Head shows the address of the first node, and my next is there, which points to current dot next, right? So basically my previous is somewhere over here, my current is over here, and my next is over here. Okay, so the first thing that I should do is, this first node over here in its next, this is going to be the last node after the reversal. So in the next part of this current node, I should put null, right? After this is the initial stage. After that, whatever operations we should do is, first thing that is turning out to be is that I will do current dot next equals to previous. This is what I am supposed to do, right? So current dot next will become null. Let me also make the changes over here. This will become null. Okay, so as soon as this become null, this connection is now sent off, because earlier it was storing the address of the second node, that's why it was pointing. But as soon as this got initialized with null, then obviously this link broke. But you can understand the difference, that still my next is pointing to the broken part of the linked list. That's why we don't lose the track. Now after we have just kind of reversed this particular thing, the first node, I have reversed it, I can say. Earlier it was pointing to 200, now it is pointing to null. So we have reversed it. Now what I should do is, I should increment all my pointers. I should move them one place ahead, right? From here to here. So how can I do that? Let me just show you. This was my previous, this was my current. So initially I should move my previous to current first, because if I move my current earlier first, then previous will move to which place? That pointer is lost. So first I will move my previous. So I will move my previous to wherever my current is. Then I should move my current to wherever my next is. So my current will move to the next part. Now my current is pointing to this portion. After the end of these two lines over here, my current is over here. So this current is basically nothing but 200. So 200 dot next is basically the address of next node. So that will be my new next. So my next will go to where? Current dot next. I hope this part is clear, because current is now pointing to this node over here. So current dot next is the address of the next node. So if I assign my next to current dot next, so basically what will happen is, my next will be pointing over here, right? And previously my P also got incremented. So after these 4 lines of iteration, this link would have been broken and we would have incremented all our P, C and N pointers, right? After that, you see, if I just run these lines again, my algorithm is solved only, because In this step also we have to do that only. We have to first reverse where whatever my current node is, I need to reverse that. Previously it was pointing to 200, we made that point to the previous. Now what is the value of previous, guys? At this position the value of previous is 100, that's why it is pointing to this node with the address 100 over here. So current dot next will become previous, which is 100. So current dot next is basically this portion over here, this is current, and current dot next is this one. It will be assigned with previous, which is 100. So over here I will store what? 100 will be stored. As soon as this becomes 100, there will be a link formed like that. This link will be formed and this link will be eliminated. So this is now the new position. Now again what will happen? I will need to move my P, C and N in these three lines. So what I'll do is I will move them. So this will come over here. You can just dry run. It will be the same thing. The previous is moving to current. Then my current is moving to next and I am assigning next to the next variable. Right. Over here also you will do the same thing. What you will do is current dot next you will put as previous. My previous is basically 200 because this is pointing to the node with address 200. Right. So as soon as this 200 comes, this link is reversed, and as soon as this link is reversed, basically this link breaks over here. I hope you are understanding. Next what we will do, we have lost connection, but still next pointer is there to connect the linked list. I will move these three things again. I will move these three things again, and I will again perform the same things. What will happen is this link will be formed because over here we will be storing 300, and also the last link that I removed, that will also be removed. After that again my PCN will move, right? It will move. So after it moved, guys, we would try to make this connection as well over here. So for this connection I would need to remove this null and make current dot next equals to previous. Previous is nothing but 400. So this will become 400. And now how will you know that the iteration has ended? Basically my next is now pointing to null. Earlier it was pointing to 500, then we went to 500 dot next, which was null earlier. So as soon as my next is pointing to the last, is pointing to null, I am sure that the entire linked list has been reversed. So I will stop iterating these four statements. We were iterating these four statements at every iteration, right? So this was basically enclosed within a loop. Now once my next is equals to null, this iteration will stop and these steps will not be performed. But still we have one particular piece of thing left, which is this head part is still pointing to the last node, which is pointing to null. So head should point to this particular node. So at the end what we will do is I will tell that my head will be equals to current, right? And then we will be returning this head. This then once I assign head with current, basically this connection over here will be found and this connection will be broken. So basically the linked list will become here to here, then here, like this way it will be reversed, right? So that is the whole logic, right? This is the initialization part. The pointers will be initialized with these values over here, and this is your iteration part until your next reaches to null. These are the operations that you need to do. As simple as that. Now I will be before coding it up, let me show you a visualization. So basically, what is the while statement that I should write? The while statement should be that my next is not equals to null. So when my next is not equals to null, then only these four lines of statement should run. Simple. Now, if you closely observe, before this particular link was made, the last to the second last, then only in this iteration, after the link between the node 400 to 300 was made, then after that only we shifted all the things. Then only this condition got violated, that null is not equals to null, because null became null after n became null after that only next. So basically the while loop will not make the last node to the second last node connection. We have to come out of the while loop, and then I need to do this thing, that my current dot next should be equals to previous. This line I should write again, so the last connection is made over here, and also I should write that head is equals to current, so that the head starts pointing to the last node over here, which is the new first node. So these two things I need to do after I break out of the while loop, right? So that is what I want you to visualize, that what are the cases, like if there are two nodes in the linked list, then how the things will behave. Suppose over here the address of this node is 100, so it will be 100 over here, it will be 200 over here, and it will be null, and any value, let any value be stored. Suppose 36 and 37 are stored, okay, and over here suppose 100 is stored, and over here there is null, and suppose 7 is stored over here, okay. So in these cases what I will do is, over here also I will assign my previous to null, my current will be pointing to this node, and my next is basically current dot next is 200, so it will be pointing to this node over here. So it is fine, we can proceed eventually, because in the after the first iteration only my next will become null, but before that only this connection will be made null, and only the second last connection will be left. I will be doing that outside the loop. So this is kind of fine. But over here, if there are only one node, then will it be fine? Let's check. Suppose what I'm saying is previous will be null, previous will be null, this will be my current, okay. Concentrate on the first two lines, previous will be null, current will be head, right. So current will be head, no problem. Then my next will be current dot next, which is null. So in this case there is no problem, because current dot next is basically 100 dot next, which is null. Then when I come to this while loop, it will be, this condition will never match that null, in next is not equals to null, because next will be null from the beginning only. So this while loop will never run. So basically the last part is still remaining, my current dot next. This, after coming out of the loop, I said that I will be doing two things, this current dot next equals to prev and head equals to current. So basically current dot next is basically referring to this part over here, that will be that will be equals to previous, which is null itself, and then my head will again point to this thing. So basically a single node, if it is reversed, it remains the same only, right, and my entire code is normalized for that as well. The only problem is when there are no nodes. See, in the this is Leetcode 206. This is a Leetcode is pretty standard. I just took the opportunity to give you a little bit of insight about linked list, the theory and the basic part. So over here you can see that there is this test case where there are no list. In that case there will be a problem. What will be the problem? The problem is it will do current equals to head. So basically your current will be null only, because your head is null. There are no things that are present over here in this third example. Head is null only. So what will happen is, when you, after assigning your current to head, you will do next equals to current dot next. Current is null basically. So if you try to do null dot next, you will get a null pointer exception. So for a case where there are no nodes, there are zero nodes, we need to separately take care of that. A separate case, edge case would be written for that. So what will be that test case? I will be starting with that test case only, that if my head is null from before only, then obviously I should return null. You can return null, or you can return head which is null, right. After that what I will do is, I would need to take 3 pointers. So these are list nodes. So this list node previous will be there, which I will assign it to null in the beginning. Then I will have my list node current, which is pointing to head, and my list node next, which will be pointing to my current dot next, right. After that what I will do, I will iterate until my next is not equals to null. Until my next has a particular value, this while loop will run. So what I will do inside this while loop, first the current node I need to make it connect with the previous node. So basically in current dot next I will give the address of the previous node. So previous node's address is stored in prev only, because prev was pointing to the previous node. After that what I will do is, I will move my prev to current. After that I will move my current to next, and my next will become what? Current is now pointing to the same node as next. You can do next equals to next dot next, or you can do current dot next, right. So this is how you iterate. Once I come out of the while loop, the last connection of the node will be pending. So what we'll do is, current dot next will have the previous value, right, and lastly my head should be pointing to the current element. Yes guys, that is it. Now I will just return this head, because I need to return a list node in this question, right. pretty standard question. I hope you read this in such a way that you don't need to read it again in your life. Cool, beats 100%. Also guys, in the description there is this follow-up where they have also asked you to write the recursive code of this. I would highly recommend you guys to do it on your own. Otherwise you might have noticed that I have kind of noticed that I have not made videos about recursion. There were certain questions on recursion and backtracking. I'll be trying to cover it up later, right? So I will be doing it then only. Cool guys, you can try it out on your own. Thank you.